Now, the next question in the set was a long question, a 55-mark question. So we're shown a diagram here and certain information filled in on it. We can see straight away that we have an isosceles right-angled triangle here from these 2 marks. So let's fill in that we know that this is 45 degrees. Okay, we also know that this must be, because of this right-angled triangle, that must be 60 degrees. But there's other ways of finding that out as well. And we can consider the triangle ABC when we're answering part 1 here, the triangle ABC, because they've asked us to explain why this is 105 degrees. So we can go the long way about it if we want, or we can just use the fact that 3 angles in a triangle add up to 180 degrees. 3 angles in a triangle add to 180 degrees. That's one of our theorems. So therefore, the angle BCA, that's the full angle here, is going to be 180 minus the 30 down here and the 45 down here. So that's 75, and that's equal to 105 degrees. So there's our full explanation. If you just did the calculation, you probably get full marks, but it's always good to write down where that's coming from. Now, they tell us that the horizontal distance from A to B is 100 meters. So there's some trigonometry coming in here now. That's 100 meters. Use the triangle ABC, to find the length of y. So let's look what we know, write down what we know on its own diagram. A, B, C, we have 105 degrees here, we've 30 degrees here, we've 45 degrees here, and we know that this is 100, and they're asking us to find this distance y. Now this is not a right-angled triangle. So if it's not a right-angled triangle, that means you're either going to use the sine rule or the cosine rule. The sine rule is slightly easier to use than the cosine rule, but sometimes it doesn't work. How do you know which one to use? Well, I recommend you try the sine rule first, and if it doesn't work, if you can't get the answer from it, and you'll know from the moment you write it down whether you've got one unknown or 2, then you can use the cosine rule if the sine rule doesn't work. So the sine rule tells me that the length of a side over the sine of the angle opposite it will be in proportion. I can do it, any length over the sine of the side opposite is equal to another length over the sine of the side opposite that. Okay, so we match them up like that, and it's in the log tables using A, B, and C. So what I can say here is that y over sine of 30, because 30 is across from it, is equal to 100 over sine 105. And then I'd multiply across by that sine 30. So y is going to be sine 30 multiplied by 100 over sine 105. And I would do that in my calculator in one step. Make sure your calculator is in degree mode. Mine's in radians at the moment. So I need to change that to degrees, because I'm working in degrees. You get the wrong answer if it's stuck in radian mode. So I have sine of 30 multiplied by 100 over sine of 105. I'm going to get a decimal because I know that sine of 105 is not a nice neat angle. And I get 51.76. Let's check one decimal place. So that's approximately 51.8. Let me check units, meters. Okay, so always check that you've answered the question and in the format that they're asking for as well. Once you have a piece of information like that, put it onto your diagram straight away, because if there are follow-up questions, you're going to use it. Okay, so not a right angle triangle, so either the sine rule or the cosine rule. Now, the next part. Using your answer to A part 3, A part 2 or otherwise, find the value of h and the value of x. So the height of my mast, h, let me show the diagram again. I'm going to use this right-angled triangle here. So I know that I have 51.8 here, 45 here. I don't know this distance here, and I don't know this distance here, the height of my mast, but I do know that those are the same. So now it is a right-angled triangle, and right-angled triangles are always either Pythagoras or Sohcahtoa. What do I mean by Sohcahtoa? I mean, I look at my angle, my opposite, my hypotenuse, and my adjacent, and I use those to work out the value of a missing side. Now, Pythagoras would work here as well because this and this are the same. So you can actually do this one either way, but I have a preference for Sohcahtoa, I have to say. The side I'm looking for is the opposite. The side I'm given is the hypotenuse. So I'm going to be using sine. Sine of 45 is my missing side divided by my hypotenuse, 51.8. It's a bit confusing that I've used h here and h for hypotenuse, so you can always change up those letters if they're making it confusing for you. When the unknown is on top, you multiply. So h is going to be 51.8 multiplied by sine of 45. And again, they're asking it for one decimal place, and it is meters, which we discovered the last time as well. So 51.8 multiplied by sine of 45, and we get 36.6 meters. Okay, so back here, that's 36.6, and that's 36.6 as well. So now can I find x, my missing side here? I can, of course. I'll sketch out that triangle. Same height, 36.6, right-angled triangle. X we don't know, but we do know my 30 degrees down here. So again, now I could work out this side as well because I know the 100 meters all the way across, but this is fine. X is my hypotenuse, and this is my opposite. So again, I'm going to use sine. Sine of 30 is 36.6 divided by x. This time, my unknown is on the bottom. So that means I divide by sine. You can do it by algebra, but it's as easy to learn these off as a shortcut. So x is going to be 36.6 divided by sine of 30. So the last time I multiplied, this time I divide. It's all about where the unknown is. So I'll do this in my calculator in one step. 36.6 divided by sine of 30. Maybe what about 73? 73.2 meters. And you will lose a mark if you don't put in those units because the question included the units. Right, okay, part B then.